All right, let's talk linear programming on question 7. In the description box, there's going to be links for other questions that I've answered for this question paper. Now, learn again. We are given a scenario, right? We are given a scenario, but take note, take note. They gave us some constraints, okay? So if you were in level 4, they were just going to give you this statement for you to go through. Funda, you're going to read through the statement. After reading through, you would have to write down these constraints on your own. Okay, but level 3, they give you the constraints. When your only task is just to do what? It's just to plot. Okay, it's just to plot or sketch the constraints. All right. So learn again, but let's just go over the statement, even though they give us the constraints. A factory employs unskilled workers at 1,000 rand per week and skilled workers at 2,000 rand per week. The payroll should not exceed 90,000 rand per week. To keep going, at least 50 operators are necessary, right? At least 50 operators are necessary. Furthermore, regulations determine that the number of skilled workers should be at least half that of the unskilled workers. So, what the last statement is saying, the number of skilled workers should be less than the number of unskilled workers. By how much? It should be half of the number of unskilled workers. Okay? But let X be the number of unskilled workers and Y the number of skilled workers. The following constraints are obtained. Okay. So that ungabi confused once you start writing. This is constraint number 1. This is going to be plotted. This is constraint number 2. This will be plotted. Constraint number 3 will be plotted. This thing, it's what we call implicit constraints, right? Implicit constraints. This will be plotted as well, but not directly so. See our plotter, in fact, let me just say, we're not plotting them. They're just there to keep our constraints to be captured or in the first quadrant. Okay, so our implicit constraints, they are there. You know, let me just say that. Okay, I will highlight our implicit constraints. Actually, the implicit constraints are the y-intercept, the y-axis and the x-axis, right? The y-axis and the x-axis in the first quadrant. Finish and clear. And then this is not a constraint. This is not a constraint. The x, comma, y element of natural numbers. It's simply saying to us, the numbers we are dealing with, they are natural numbers, right? So it means that to x, no y, are natural numbers. What are natural numbers? All the numbers starting from 0 to infinity. All the whole numbers starting from 0 to infinity, right? I cannot have 3,5 skilled workers or 2,1 skilled workers or 0,5 unskilled workers. It doesn't work like that. So it should be a whole number. 5 workers, 5 skilled workers, 7 unskilled workers, something like that. Okay? So 7.1, sketch these inequalities on annexure B attached. Alright, so 7.1, how do we sketch our inequalities? Now pay attention. You sketch ama constraints wakho by getting the x and y intercept for each constraint, right? Each constraint. Which constraints? The 1, 2, and 3. The explicit constraints. Explicit constraints. You're going to take your explicit constraints and then solve by getting the x-intercept and then the y-intercept for each constraint, right? So let's do that. Sizothi-ke, let's take the first constraint. 1, it's 1000 x plus 2000 y less than or equal to 90,000. Okay, so we want the y inter as well as the x intercept. The y inter, we let x to be 0. We let x to be 0. Okay, so this is what 1000 open bracket 0 plus 2000y equal to 90,000. 1, 2, 3. I'm removing the inequality sign in this case. So 1000 times 0, that's 0. So 2000 y, 90,000 divided by 2000 on both sides. 2000 cancel, 90 over 2, that's 45. So it's gonna be 45. And then x intercept, you do the same thing. Now you say y be equal to 0. 1000, keep the x, plus 20. Ooh, 2000 open bracket 0 equal to 90. 1, 2, 3. Then it's 1000 x equal to 90,000 divided by 1000. 1000 x is equal to, lay cancel this one, salano 90. All right, so these coordinates, the y-intercept is going to be 0 and 45, and then this one is going to be 90 and 0. Okay, and then for the next constraint, that's gonna be constraint number 2. We have the x plus y greater or equal to 50. So by simplifying this, making x the getting the y and the x intercept as well. So the y inter, you repeat the same process as above, right? You let x to be 0. By letting x to be 0, utoluguti your y, the y is gonna be equal to 50. So the coordinate is gonna be what? It's gonna be 0 and 50. And then x intercept, even here, x intercept, we're gonna say let y to be 0. Let y be 0. Therefore, my x is gonna be equal to 50 as well, by repeating the same process as above. 50 and 0. Okay, so these are the x and the y intercept for the first two constraints. I'm gonna write down these coordinates. The number one, sino 0 and 45 y intercept, and then sibano 90 and 0 the x intercept. Done for the first one. And then for the second one, it's 0 and 50, no, 50 and 0, 50 and 0. Okay, now let me hide these calculations. Yeah, let me hide them. And then lana, this is constraint 1, constraint 2, constraint number 3. I want to discuss this one alone, without the mess on the previous slide. Y greater or equal to x over 2. We want to find the x-intercept as well as the y-intercept. Okay, the y-intercept as well as the x-intercept. Alright, so let's start with the y-intercept. So lana, the y-intercept, how do we get the y-intercept? We let x to be 0. Then y is equal to, I remove the inequality sign and placed an equal sign. It's gonna be 0 over 2. What's the answer? It's 0, right? it's 0. So I let x to be 0, then in turn with my y is also 0. Okay, 0. What about the x-intercept again? I'm trying to explain this thing step by step because it might be a bit of a challenge. I'm trying to understand that fraction. And then y x-intercept is going to be allowing y to be 0. So we come here as it is 0 is equal to x over 2. So multiply by 2, so multiply by 2 is total 0 up. Then x is equal to, my y was 0 when I was calculating x-intercept. Now my x is also 0. It means that the coordinates are going to be 0 and 0. I'm a coordinates are my final, right? So it means that if I have a graph that looks like this, my third constraint will go through the origin, will pass through the origin. Okay, the 0 and 0 is the origin. I represented the coordinates of the origin. Okay, now solvile wonke ama constraints with 3. All the 3 constraints. Lana, there's only one coordinate. It's what? 0 and 0. But here's the catch. Here's the catch. Now, how do you know with your line is gonna go like this or go like this or go like that? Yeah, what? So you need to find a workaround the slope, the steepness of that line. But we're gonna discuss that. We're gonna discuss that just now. I'm gonna plot the first constraint and the second constraint. Then the last one I'll plot the cleaning. So let me okay, let me hide low. Can we? Okay. Okay. So these are my constraints. Lana, I need to erase. I need to erase this part. All right. Yeah. There we go. There we go. Okay. So we come this side to get much. So this is the this is a grid SO7 for plotting our inequalities. All right, so maybe let's choose a scale of, let's use a scale of 10. So Lana, it's gonna be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. Okay, so maybe nangasusale black, man. Let's use something like yellow. Yeah, yellow. I think it's gonna work. So it's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. And then ngapha it's gonna be 10 as well. It's gonna be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, 100. And then we can plot by doing this. This is the origin. This is the origin. Like no 0. Okay, no 0 up here. And now we're gonna plot our points way to here. Let's start no 0 and 45, 40, 45. That's 10. 45 for somewhere la. 45, 90. Okay. 0 and 45 now. 0 and 45. 0 and 45. It's the y-intercept. 90 and 0. 90 and 0 now. It's the x-intercept. It's the x-intercept. Then the second equation, 50 and 0, that's the x-intercept. Now x-intercept. 50 and 0. No, 0 and 50, the y-intercept. The y-intercept. 0 and 50. Then we connect this with that, this with that. We now have our first two constraints. We have our first two constraints. The last constraint, this is the question I was asking. Maybe let's use green. This is the question I was asking. Is my line gonna go like this, or go like that, or go like this, right? Which one out of the three? We don't know until you do the following. So since you have this, you have that, and we ask it passes through the origin. What is the origin? The origin, I'm a coordinate corner now, 0 and 0. It's this point right here. Okay, so you need at least 1 point, at least 1 point, né? At least 1 point. So your equation, it's y, it's what? It's y greater or equal to bani x over 2. All right, so you need to choose an x value, any x value that you want, any x value, about 30, about 40, about 60, anything, and then you substitute it here. So by doing that, uzothola the y value. So what is x? Let's say maybe I choose x to be 40. I'm gonna substitute the 40. 40 divided by 2, that's 20. 40 divided by 2, that's 20. So it means that I now have a coordinate that I can plot. It's actually a point that lies on the line, right? So, I chose x to be 40 and y to be 20. So this point I can plot. So what I did is I calculated a point along the line so that I can plot it and get the shape of the line or the slope for the line. All right, so lo 40 long is ketele yen. This 20 I calculated through this formula, right? So the x I chose, the y I calculated through the formula. So I wanna see what line lam yohamba njani. So I chose 40, I told out 20. So it means that the line is gonna go from this origin point to that point we calculated. All right, so now I'm a constraint one. So this is my plot. Okay, this is my plot. This is my plot. Then on the next question, 7.2. 7.2. Shade and indicate the feasible region on a sketch in 7.1 for 2 marks. All right, so this is when you now start considering inequality signs wako, so that you can shade your feasible region. Now, if you have an inequality sign that is bigger than or equal to something, your shader above the line. If you have an inequality sign that is less than or equal to, your shader below the line. So let's start with the first constraint. So constraint number 1. Constraint number 1. Okay, constraint number 1, we have a less than sign. So constraint number 1 was this line as you plot here. Okay, so it's pointing down, pointing down, pointing down, pointing down. Okay, why? Because of the inequality sign is less than or equal to. So this is constraint number 2. Constraint number 2, it's above, so it's gonna be shading above the line, like this, like this, like this. Okay, and then for the third one, it's above as well. So see shader above, above, above. Now, how do you identify your feasible region again? The feasible region, it's that region or that area where all of the lines are shading into. okay, are shading into. So uma uthatha ukubheka this area engishada ngobgreen la, this is my feasible region because all of the lines are pointing in this area, So this is shade 1, shade 2, shade 3, shade 4. The answer is to 9, by the way, right? 9 area, the shaded one. But let me show you why number 1, number 2, number 3, and number 4 are not the feasible regions. Beg, this line is pointing in here. This line is pointing into shade number 2. But this line, line number 2 is not pointing into area number 2. So that is why we're not considering this one as the feasible region. Same goes with this line. I mean shade number 1, this one. This is not the feasible region because line number 2 is pointing away from that area, so we cannot consider that one as the feasible region. The feasible region, it should be the area or the shade where all of the lines are shading into. So it happens to be this one right here. Okay, so this is my feasible region. Now lana again, they want us to 7.3, they want us to determine from the graph the minimum and maximum number of unskilled workers that should be employed. The minimum and maximum number of unskilled workers that should be employed. Okay, so how do you work out the minimum and maximum? So you go to the feasible region or you plot it, right? The feasible region you plotted. So this is my feasible region. So on the feasible region, you need the coordinates of all the corners. Lana, in fact, the point. So the coordinates for A, it's 10 and 40. It's 10 and 40. And then OP, let's call this B. OP, it's seems like it's 45, and then 20. Yeah, no, I'm plotting to scale, but lana it's 20 la. It should read 20, and then C, that should be 35. That should be 35. Yeah, more or less 35, and then ngapha it's gonna be 15. So now my coordinates got C now. C, that's gonna be 35 and 15. Okay, so now my coordinates now. A, which is this, I think 10 and 40, and then snow B happens to be 45 and 20. Then we also have C, the coordinates for C, that is 35 and 15. Okay, 35 and 15. All right. Okay, but if we label our graph here now, the x-axis represents our unskilled workers. How do I know this? Basically, what is it? Let x be the number of unskilled workers. Let y be the number of skilled workers. So ngapha we have skilled workers. Okay, so it means that for all x values, coordinates, this is my x value, it's 10. My x value is 45. My x value is 35. Right? For the A, B, and C. Now, out of the 3 x values, which one is the minimum? Minimum 10. So this is minimum 10 what? 10 what? I'm sure these are x values. So 10 is the minimum out of the 3 values. So it means that I need a minimum of 10 unskilled. I shall keep about maximum and minimum, and then maximum is equal to 45. Is equal to 45 skill, no, not skilled. Oh, okay, so bafuna both skilled and unskilled. I mean both unskilled, both unskilled. So the minimum and the maximum it's for the unskilled workers. Okay, so it's not gonna be 40, but it's 45. It's 45. So this is the number of unskilled workers, unskilled, right? So the minimum is this 10. The maximum is the 45 unskilled workers. Yeah, this problem is weird, Nyana. So, however, you can manage. It's not like it's those type of problems where there's a maximizing of a profit or manufacturing something. Lana, we're getting the minimum and maximum values for the number of unskilled workers. So if say maybe bebafuna, sorry, the minimum and maximum for the skilled workers, boyopega the y values. Then you take out the minimum and the maximum. All right. So this concludes our discussion. Lanabu question 7, the linear programming. I hope we enjoyed it. If you did, ungakhohlwa ukusubscribe, ungakhohlwa ukulike, sharele nomngane wakho man. Yeah, let's talk in the comment section if you have any questions. For now, signing out. Catch you on the next one. Bye bye.